So this is another way that I'll show problems, and this is the way that you might see some problems on quizzes and exams. I've got a molecule. I've got a line under the molecule where I'd like you to name it. I add it to something. There's an opportunity to put a catalyst above the reaction arrow, and then you draw the product or products and name them. And then you'll also tell me what kind of a reaction it is. So let's start by naming our reactant. We see here that we have a cyclic starting material, so we want to count how many carbons are in this starting material. At first glance, I can tell that it's a pentagon, which means it has 5 sides. If you count, start with the double bond, count 1, 2, 3, 4, 5. You'd actually want to start on this side of the double bond, 1, 2, 3, 4, 5. So this is going to be pentene because there's a double bond, and it would be classified as cyclopentene. So I'm going to start by writing that. The next thing that we want to do is we want to say where the double bond is. And what I'll do is I'll start right here and put 1, 2, 3, 4, 5. So it's 1 cyclopentene. And then we have 2 branches. Those 2 branches occur at carbons number 2 and carbons number 3. So we're going to call this 2, 3. The branches are both 1 carbon long, so 2,3-dimethyl. Cyclopentene. 2,3-dimethyl cyclopentene. Now we're going to do our reaction. This is a hydrohalogenation reaction of an alkene. We're adding HBr. So the name of this reaction is hydrohalogenation. And you could also say of an alkene. But the part that is most important to me is the hydrohalogenation part. Now, if you remember, in hydrohalogenation, there is no catalyst. So that box right there is just there to be sure that you are confident in your reactions. In the case of hydrohalogenation of alkenes, there are no catalysts. And now we go on to the product. As in the previous hydrohalogenation of an alkene example that I showed you, the H goes on one of the carbons of the double bond, and the Br goes on another one of the carbons of the double bond. Carbon 1 and carbon 2 are going to receive the 2 pieces of this addition. Now, in order to decide which one gets which, what gets the H and what gets the Br, we need to use Markovnikov's rule. Okay, and Markovnikov's rule is H goes on the carbon with more H. And the Br, or if this was a chlorination, so Cl, goes on the carbon with more carbon attached. Okay? So if we look at carbon number 1, what we see is this carbon number 1 is attached to carbon number 5 and attached to carbon number 2. So there's 2 carbons attached, and there's 1 hydrogen on here because we need to make up the 4 bonds to carbon. So we can think of there being a hydrogen here. So I'm going to put a little dotted line and an H. Okay. On carbon number 2, this carbon is attached to the branch, attached to carbon number 3, and attached to carbon number 1. So there are no H's on that carbon. Therefore, the H is going to attach to carbon number 1. So what I'm going to do is I'm going to redraw the carbon structure. Remember, in all of these reactions, the carbon structure does not change. We can lose double bonds, but we do not change any carbon-carbon bonds. So I'm going to draw my now it's cyclopentane because the double bond will be gone. Okay, and I have a branch, and I have a branch, and I'm going to go ahead and add my hydrogen from the HBr right here on this carbon that had more hydrogen. Now I'm adding it in my mind because I know that in the line bond structure, this is implied as having having 4 bonds around the carbon, so there are 2 hydrogens there. The Br, therefore, goes on what was carbon number 2. So here I'm going to put my Br. And now this carbon has 4 bonds to it. This carbon has the new hydrogen, as well as the hydrogen that was always there. Now, in order to name this, we're going to renumber it, because now we have a bromine here, nothing on this one, so this will be carbon number 1, this will be carbon number 2, and then 3, 4, 5. So we would call this 1-bromo, 1,2-dimethyl cyclopentane. So we've done a markovnikov hydrohalogenation of an alkene. The H added to the carbon that had more H's. It had an H on it already. And the bromine added to the carbon that had more carbons. So bromine added up here. This has now 2 hydrogens on it, and we have created 1-bromo, 1,2-dimethyl cyclopentane.